Hello, check. All right, people, we are back. So more than half of the paper is remaining. Let's capture some speed right now. This is the part 2 of NTA Abhyas mock test solving NEET paper number 105. तो चलो ये question करते हैं which we had seen before the break. What is the binding energy in joules per mole or kilojoules per mole of an electron in a metal whose threshold frequency for photoelectron is 3.5 into 10 to the power 13 per second. So how do we do this, people? Energy equals to h times nu. Simple as that. ठीक है. So this will be energy for one particular system. Yeah, this will be energy for only one particular atom of the metal, but we have to calculate it in kilojoules per mole. So for one mole, okay, energy per mole, you have to calculate this for one mole of atoms. So this has to be multiplied into the Avogadro's number as well. So यहाँ पे आ जाएगा 6.6 into 10 to the power 34, है ना जी? ठीक है, into फ्रीक्वेंसी दे रखी है 3.5, आजा 3.5 into 10 to the power 13. This will be multiplied with 6.022 into 10 to the power 23. Yeah, this is going to be your answer. तो बस मल्टीप्लीकेशन सा करना है यार, ज़्यादा कुछ वो नहीं है. तो 6.6 into 3.5 into 6. 6 into 6 is 36. So 6.6 into 6 will be somewhere around 40. 3 into 4 will be somewhere around 12. मेरे हिसाब से the answer should be option number C. Do you understand the approximation that I did? So speed is of the essence in NEET examination. Look at the approximation I did. 6.6 into 6. Yeah, 6.6 into 6 is how much? 40 approximately, because 6 into 6 is 36. 6.6 into 6 is approximately 40. 4 into 3 is 12. Answer will be approximately something more than 12. Yeah, 4 into 3 is 12. 4 into 3.5 will be 13, something approximately 13. Do you get the idea? Okay, so that is the approximation I did. You can solve the entire question if you want to, but very quickly, just by looking at the options, you can get the answer. Chalo, next question is correct IUPAC name of this guy. अच्छा, aqua, so A पहले आएगा. Isothiocyaneto, है ना? This is NCS, है ना? So isothiocyaneto because NCS है यहाँ पे, ठीक है? So penta aqua, thiocyaneto, chromium, yeah, because in the cation you just write the name of the metal, chromium. What is the oxidation state? Zinc is generally in 2 positive, so bromine will give it 4 negative, so overall this will be 2 positive. Do you understand the logic that I told you? Zinc Br4, zinc is generally 2 positive, bromine is 1 negative into 4, so 2 negative remain on this structure. That 2 negative has to be stabilized by chromium, so this is 2 positive. So pentaqua, thiocyaneto, chromium 2, isothiocyaneto, chromium 2, किधर गया chromium 2? एक सेकंड देखते हैं, ये तो कोई सेंस बनता नहीं है इसका. chromium 3 doesn't make sense in my opinion. Yeah, chromium 3 से तो कोई भी सेंस. अच्छा, chromium 3 होना चाहिए क्या यहाँ पे? अच्छा हाँ, because we have NCS. Yeah, my silly mistake that I did over here. NCS will have a negative charge. Yeah, NCS will also have a negative charge. So I forgot calculating that negative charge. Now that I realize, this has to be a 3 positive. Okay, so NCS negative and a 2 negative from here. Total is 3. So pentaqua, isothiocyaneto, chromium 3, tetrabromozincate, because this is the negatively charged ion. So negatively charged ions have to end with 8. Option number C makes the most amount of sense. ठीक है? So pentaqua, isothiocyaneto, chromium 3, tetrabromozincate. ठीक है जी? Got it? NCS पे भी एक negative charge आएगा. So I hope you understand this question. Let's move on to the next one. Simple basic logic of nomenclature. चलो आगे बढ़ते हैं. ये थोड़ा weird question है. Okay, this is a little weird question. Okay, this is a little not that typical a question, and they should have given better information in the reagents anyway. So what they are doing is, well, we'll write all the reactions over here. So you have C, triple bond C, and you reacted with sodium in NH3. yeah, which will essentially give you NaNH2, and you know that this is a very strong base. Now let us assume that it is in excess. Okay, first of all, they should have mentioned it is in excess, but if they have not mentioned, let us assume it is in excess. So what will happen is it will cause the proton to be lost from both the terminals. Yeah, तो यहाँ पे बन जाएगा C triple bond C. You know that alkynes are pretty acidic. Terminal alkynes are pretty acidic. So you will get C triple bond C negative on one side, negative on the other side, and then you're reacting it with DCl. You're reacting it with DCl. So you can assume that the attack will happen from both sides, and eventually what you will get is, okay, you will get a C triple bond C with a deuterium on the left side and the deuterium on the right side. Fine. Both sides you will get your deuterium. Now the last reaction is, I think it is incomplete over here. Let's try to figure out what's going on. So this is what we have for now. C triple bond C, both sides D. Then you have dicyamyl borane. Okay, this SiA2BH, sorry, SiA2BH is also known as dicyamyl borane. Okay, dicyamyl borane. Now you'll be wondering ये dicyamyl borane क्या है? I'll show you the structure, then you'll realize बहुत ही simple सी चीज़ है. Just a second, okay? I'm going to show you the structure. It's a very simple structure. It's just a bromine substitute, boron substituted with some carbon chains. Okay, this is your dicyamyl borane. Okay, boron, one hydrogen, and then rest of the things over here. Okay. So my dear friends, what this dicyamyl borane does, this dicyamyl borane can be used for your hydroboration reaction. Do you remember hydroboration reaction? Hydroboration reaction mein, once you take an alkene, what happens is let's take a cis alkene for easier drawing. When you react it with a boron like compound, for example a dicyamyl borane, what will happen is on one side you will have hydrogen, on the other side you will have some boron compound. Yes, pardon me for my erratic thought process right now. So what happens is, if you have a terminal alkyne, the boron will associate itself towards the outer side. Okay? So you know that this is an anti-Markovnikov reaction. Eventually, when we react it with H2O2, we replace the boron with an OH group. That is the reaction that we do. This is your hydroboration oxidation. But over here only part 1 is given for this reaction. Part 2 for this reaction is not given. Part 2 can either be H2O2, which is your hydroboration oxidation. If it is something like CH3COOH, then this reaction will become a little different. If you put a reducing agent later, or if you put a hydride ion providing reagent again, let's say NaBH4 or something, that will be a different reaction. So what will happen, my dear friends, onto this particular structure, onto one of the double bonds, what you can do is add, okay, on one of the pi bonds, you can add the dicyamyl borane. So यहाँ पे होगा C double bond C, this is D, and at the bottom, as a syn addition, you can put a hydrogen and you can put the boron wala species. Then you can replace this boron just to get a proper answer. Okay, just to get the proper answer, you can replace this with a hydrogen as well. Okay, so you can use CH3COOH over here in the second step. You can use acetic acid, and that can eventually provide you option number C as your correct answer. Okay, got it? चलेगा? Pum, 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 pum. चलो जी, तो ये लिख लो एक बारी. It's a weird question. You can write it down. All right. Someone was asking about C1-OFF reagent. That is a different thing for testing some sugars, man. Okay. RN saying is NEET tougher than the NTA Abhyas series? No, it will be the same level. तो कुछ खास different नहीं होगा. Okay. Anyway, let's move on to the next question. In two hydrogen atoms, X and Y, the electrons move around in circular orbits of radius r and 4r respectively. People, this simply has to do with the formulae of the hydrogen atom, Bohr's model of the atom. So you know that the radius on the Bohr's model of the atom is equal to how much? Radius is a naught. A naught is the radius of the first orbit into n square by z. More is the number of the orbit, the higher will be the radius. Yes, this is what we have. And you know that velocity in any orbit is v naught. V naught is the velocity of the electron in the first orbit, of course, into z divided by n. Z is the atomic number, n is the number of the orbit. Now, since we are talking about hydrogen atom, these are formula from the Bohr's model of the atom. Please revise it if you've forgotten that. अपन इसको हटाते हैं यहाँ से, and let's put 1 over there because hydrogen atom. So my dear friends, time taken is equal to distance upon speed, which is equal to radius upon v is a speed basically. It's not velocity technically because the sign keeps on changing all the time. It's a circular motion here. So in chemistry we generally replace the terms velocity and speed. Chemists are not really worried about physics. So velocity and speed is the same thing for us. So this v naught is actually speed. ठीक है. So radius upon speed करेंगे time आ जाएगा. तो यहाँ से क्या करना है? A naught into n square divided by v naught divided by v naught into 1 by n. So this n will go upstairs. This will become n cube. So my dear friends, the time period will be proportional to n cube. From this analysis, we have figured out that time period is proportional to n cube and the radius is proportional to n square. Fine. So now that we have these two pieces of information, all we need to do, x and y, 1:4 is the radius. So n will be 1 for x, 2 for y. So time periods will be in the ratio of 1:8. Option C is correct. Question A. Not going to spend more time on this particular question. Let's move on to the next one. The value of Henry's law constant for few gases at 298 Kelvin is given below. Arrange these in the increasing order of their solubility. So my dear friends, at a certain pressure, at a certain vapor pressure of the gas, we say that this is equal to Henry's constant into the mole fraction in the liquid. So if we have a constant pressure, if we have the same setting for all the gases, if I have more Henry's constant, I will have less solubility. Mole fraction in liquid, Henry's constant, vapor pressure. ठीक है. तो my dear friends, if we have all the other conditions the same, if I have more Henry's constant, my solubility is lesser. I will have lesser mole fraction inside the liquid component. So simply what I have to see is higher KH, lower solubility. N2 will have the least solubility, then H2, then O2. Option number D is the correct answer. Basic application of Henry's law, nothing more complicated about it. Always remember that solubility and Henry's law are inversely proportional to each other. चलो जी, आगे बढ़ जाएंगे. 3 Faradays of electricity. 3 Faraday, 3 into 96500 coulombs of electricity is passed through solutions of AgNO3, NiSO4 and COCl3. So you have Ag positive, you have Ni sulfate, so 2 positive, yeah, H2SO4, NiSO4, 2 positive, and COCl3, 3 chlorines, so cobalt has to be in its 3 positive oxidation state. Now my dear friends, if I provide this guy 1 electron, this becomes silver. If I provide this guy 2 electrons, this becomes nickel. If I provide this guy 3 electrons, this becomes cobalt. So if I am providing it 1 Faraday of electrons, 1 Faraday electrons is 1 mole of electrons. So 1 mole of electrons will give me, okay, 3 Faraday electrons से अपने पास क्या बनेगा वो सोचते हैं. I'm going a little faster because we have too many questions. Yeah, so sorry if I am a little too hurried right now. Anyway, so 3 Faradays of electrons, 3 Faraday of electrons. Looked like iron. 3 Faraday of electrons, if we have 3 moles of silver can be formed. If I have 3 Faraday electrons, 3 by 2 moles of nickel can be formed. If I have 3 Faraday of electrons, all 3 will be used up for only 1 cobalt. 3 by 3 essentially 1 mole of cobalt will be formed. Yes. So my dear friends, this is the ratio that you have to calculate. Ratio क्या आ जाएगा? 3 by 2 1. If we have to convert it into a simple ratio, 6 is to 3 is to 2. Yeah. So the answer becomes option number D. Very simple question once again. Always remember that 1 Faraday of charge will give you 1 mole of electrons. चलो जी आगे बढ़ जाएंगे. 2 moles of an ideal gas is expanded isothermally and reversibly from 2 liter to 20 liter at 300 Kelvin. The enthalpy change in the process. Hey Rabba. In an isothermal process, and your internal energy and enthalpy don't change. Yeah, in an isothermal process, NCP delta T is 0, NCV delta T is 0. You must be wondering, sir, but this is for CP, that is for CV. These are state governed functions. Yeah, state function. Delta H is a state function. Delta क्या कहते हैं, your delta U is also a state function. If you are not convinced like this, let me tell you in a different manner. Delta H is equal to delta U plus delta PV. Since this is an isothermal process, delta PV is 0. P into V is a constant value, isothermal process. Delta U is already 0 because isothermal processes में internal energy change is 0. Why? Because for an ideal gas, internal energy is equal to 3 by 2 RT, 3 by 2 nRT if you want to talk about the total internal energy of the gas. 3 by 2 nRT. If T is not changing, U is not changing. So my dear friends, enthalpy change is 0. Remember, isothermal processes, enthalpy and internal energy don't change. They are state functions. Let's move on to the next question. Which of the following shapes are not possible for different values of N in XeFn molecules? So this is again a factual question. You need to remember the different fluorides that Xenon can show you. So you can have XeF2, you can have XeF4, you can also have XeF6. These are the different fluorides of Xenon found in laboratory or nature. Fine. So now when you think about their structures, if you think about XeF2, एक एक करके बनाते हैं इनका structure, ठीक है? XeF2, Xenon has 8 valence electrons in its non-bonded state. Now we are adding it to 2 fluorines. So put 1 fluorine over here, 1 fluorine over here. So what is the structure now? 1, 2, 3. 3 lone pairs, 2 bond pair structure. How do we make this 3 bond pair, 2 lone pair structure? 3 lone pair, 2 bond pair structure can be made like this. Lone pair, lone pair, lone pair, right? And you have 2 bond pairs as well. So 1 bond pair on the top, 1 bond pair on the bottom. This is a linear shape, trigonal bipyramidal geometry, linear shape. So linearity is possible. Now what about XeF4? What about XeF4? So in XeF4, इसको मैं हटा देता हूँ यहाँ से. XeF4 में 1, 2, 3, 4, 5, 6, 7, 8. Again you have to put 4 fluorines on it. We can easily make the structure over here itself. Yeah. So you have 2 lone pairs, 4 bond pairs. This is the structure. Yeah. Square planar structure. 1 lone pair on the top, 1 lone pair on the bottom. In the equatorial plane, you will have 4 fluorines at 90 degrees from each other. So that will be a square planar structure. That is also possible. Then you have your XeF6. XeF6 very simple. कुछ नहीं करना, 6 fluorine लगा देने हैं. Octahedral structure. Trigonal planar is not possible. ठीक है जी. ठीक है. Cool. Saranjan is asking XeF5 negative, what's the shape? चलो करके देख लेते हैं. XeF5 negative काफी weird सा structure हो जाएगा, पर चलो I'll still try to tell you. Extra electron because of the negative charge. You have 5 fluorines, 1, 2, 3, 4 and 5. So this is a 2 lone pair 1, 2, 3, 4, 5. 5 bond pair kind of a species. Yes. So my dear friends, over here the basic structural unit, it's an interesting question that you've asked. Basic structural unit is your pentagonal bipyramidal. Okay, so this will be 1, 2, 3, 4 and 5. Okay, so this is a pentagon that you have to form. ये pentagon थोड़ा और अच्छे से बनाता हूँ मैं, रुको. 1, 2, 3, 4 and 5. Can you see pentagon? And this is the equatorial pentagon. Okay, so this is existing in this particular plane. Then you have two axial bonds on it. My dear friends, the fun thing about pentagonal bipyramidal is that there are 72-degree interactions in two equatorial bonds. So equatorial bonds in pentagonal bipyramidal are closer compared to axial bonds. So in this case, axial bonds have less repulsion, equatorial bonds have more repulsion, and you know you have to place the lone pairs at less repulsion systems. So you will put a lone pair here, and in the pentagon you will put all your fluorines. So this becomes a pentagonal planar system. Okay, planar pentagonal system. That will be the shape. Anyway, you can call it pentagonal planar. Okay, चलो आगे बढ़ते हैं. It's a very unlikely molecule. It doesn't really exist. Anyway, equal volume of 1 molar HCl and 1 molar H2SO4 are neutralized by dilute in a solution. X and Y kilocalories of heat are liberated. What are the values? Which of these are true? देखो यार, 1 mole HCl is as good as 1 mole H positive. 1 mole H2SO4 is as good as 2 mole H positive. So this, when liberated, when titrated with NaOH, will need more OH negative. This will release more energy. I will say double the amount of energy. Yeah, this will release X amount of energy. This will release 2X amount of energy. So X is half of Y. Kya ghatiya question? I have no idea. Forget about it. Let's move on to the next question. Thak gaya main. Not really tired. I'm just thirsty. I have a little bit of water. I'll drink it. Arrange the following compounds in the order of reactivity towards SN2 reaction. Let's try to write down the structures properly to understand what's going on. Yeah. First question is CH3, CH2, Cl and the terminal CH3. Okay, terminal में CH3 है. CH2 पे बीच में 2 CH2 लगा दी. क्या घटिया स्ट्रक्चर दे दिया है इन्होंने. Yeah, so it's just a straight chain structure. CH3, CH2, 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 Cl. CH3, CH2, 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 Cl. Just named it very weird. Okay, this is your structure number 1. CH3, CH2, 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 Cl. Cool. ये हो गया. Second structure is CH3 whole twice CH. Okay, so there's a carbon which has 2 CH3 on it. CH3 whole twice CH, CH2, CH2, Cl. This is structure number 2. Structure number 3 is, thankfully it is given to us very simply. So 1, 2, 3, 4 carbons, and you have a chlorine, and on the second carbon you have this. Okay? Structure number 4 is again very crowded, as you can see this guy. If you notice carefully, all of them are 1 degree halogens. Do you realize all of them are 1 degree alkyl halides? 1 degree alkyl halide, 1 degree alkyl halide. This carbon connected to only one carbon, 1 degree alkyl halide. But on the 1 degrees, on the subsequent carbon, yeah, on the beta carbon, you can say, now we have to look at the steric hindrance on the further carbons. Okay? So this one has least steric hindrance. Of course, its rate will be very high. Yeah, this guy has no steric hindrance. So this one is a proper primary structure without any branching in it. This will have the most amount of rate. SN2 reactions mein steric hindrance has to be less. Okay, so this is the least crowded, most rate. Then you have to compare between 2 and 3. If you have to approach from this side, where is it easier to approach? I want to approach this particular carbon. Over here there is more crowding near this black carbon. Over here there is less crowding near the black carbon. Yeah, near the black carbon there is less crowding. Near the black carbon there is a lot of crowding. So my dear friends, and lastly this is very crowded, so this will have the least amount of SN2 rate. 1 2 3 4 is the answer. Option number D is the answer. So more crowding, this is the carbon that will react, yeah, more crowding around the reacting carbon, lesser is the rate for SN2 reaction. More steric hindrance, lesser is the rate for SN2 reaction. Steric hindrance is just a fancy name for crowding. Which of the following cations cannot give you borax bead test? So my dear friends, what happens in borax bead test? You get metaborates. ठीक है, बोरैक्स बीड टेस्ट में करते क्या है अपन, इवेंचुअली यू हीट इट अप विद अ बोरॉन कंपाउंड, चलते फिरते what you need to know is that you form a metaborate. What does a metaborate look like? This is your metal, this is your BO2 and some amount of BO2 is added. This BO2 has a 1 negative charge on it. ठीक है, सो यहाँ पे बन जाएगा CrBO2 thrice, COBO2 twice, AgBO2, MnBO2. The thing is, this is again a factual question. The fact is that AgBO2, the metaborate of silver, is colorless. Okay, so borax bead test is essentially when you get these metaborates that are colored in nature. When you heat them up, eventually your metaborates get formed and your reaction gives a very beautiful color. तो वो कलर नहीं आएगा इस केस में, it is colorless, hence we say that it does not give a borax bead test. Okay, ठीक है, so Ag positive ion cannot give borax bead test because the formed silver metaborate is white or colorless while the other are colored in nature. So again, from qualitative analysis, this is your question. Moving on to the next one, again very simple. Yeah, again very simple question. What is the correct sequence of increasing order of freezing point at 1 atmosphere of the following aqueous solutions? So my dear friends, you have to think about the depression in freezing point. Yeah, you have to think about the depression in freezing point. My kittens are eating my Wi-Fi wire. अगर Wi-Fi बंद हो गया तो क्लास बंद हो जाएगा. How do I prevent this from happening? I don't know. Yeah. पता नहीं क्या मजा आता है तार चबाने में. Anyway, so yeah, delta T, which is a depression in freezing point. So lower freezing point will be there for more depression. Yeah, delta T in freezing is equal to the cryoscopic constant Kf, that is the cryoscopic constant, into molality into Van 't Hoff factor. For the same molality of all of these guys, more Van 't Hoff factor will mean more depression. So more depression implies less freezing point. More depression in freezing point implies less freezing point. Yeah, so क्योंकि less freezing point अपने को चाहिए, yes, increasing order of freezing point. Urea, yeah, urea में Van 't Hoff factor is 1. Potassium chloride is KCl. Van 't Hoff factor is equal to 2. Potassium sulfate, K2SO4. Van 't Hoff factor is equal to 3, 1, 2 and third ion. Yeah, and then you have potassium phosphate, K3PO2, sorry, K3PO4. ठीक है, K3PO4 में I is equal to 1, 2, 3 and 4. So more Van 't Hoff factor, more depression. More depression implies lesser freezing point. So more Van 't Hoff factor implies lesser freezing point. The increasing order will be 4 less than 3 less than 2 less than 1. Option number D is the correct answer. काफी simple है, very simple. So this is your correct answer for the freezing point. कितने क्वेश्चन हो गए भैया? ओहो, अभी बचा है काम. 15 more questions are remaining. How are you guys supposed to do so many questions in just 1 hour? I have no idea. Chalo, let's do whatever is remaining. 15 more questions. Which one of the following compounds gives carboxylic acid with HNO2? My dear friends, do you remember diazotization? सीधा सीधा बताता हूँ आपको. If you have something like this, whatever R is, when you reacted with HNO2, eventually what will you get? you will get Rn2 positive plus H2O, and then this N2 positive can be replaced very easily. Okay, this N2 positive can act as a very good leaving group, so this can give you ROH plus N2 as your side product. ठीक है, यहाँ पे मान लो water goes and attacks over here, N2 positive is a very good leaving group, this is what happens. So you need a place where if you replace the nitrogen with an OH group, you get an acid. Look at the amide. Okay, so same reaction करना है अपने को amide के साथ. So this is your amide, this is benzamide. Okay, PH C double bond O NH2 when put in HNO2 can do a diazotization over here. You will get PH C double bond O N2 positive, which can be replaced with an OH group. So the answer is amide, benzamide, yeah, benzene's amide, benzamide. Cool, so pretty simple question. Let's move on to the next one. What is not true about N2O3? It is an equimolar mixture of, अरे भैया सब कुछ तो दिख गया. So I'll show you that structure once again. So N2O3 is formed when you add NO and NO2. They react with each other. ठीक है. Nitrogen in both cases has one unpaired electron. So those unpaired electrons can form a single bond between these two nitrogens. ठीक है. So N bond length is approximately 186 picometers. This is a fact. Bond angle around N atoms are equal. Bond angles around N are different. This is correct, this is wrong. Option number C is the answer to this question. Bond angles around N atom are different. This is what the structure of N2O3 looks like. So when you combine NO and NO2 together, this is what it forms. And on one nitrogen, this is the bond angle. On the other nitrogen, this is the bond angle. ठीक है? यहाँ पे technically speaking, this is an N double bond O. ठीक है? So you have a 105 degree angle over one side, 113 and 130 degree angle on the other side. This is just factual stuff. This is given in the NCERT in the P block chapter in the oxides of nitrogen. ठीक है? बढ़िया, ये भी हो गया. Okay, Dhiren is saying, do we need to remember the bond angles? Just remember that the angles are different. No need to remember the exact bond angles. That is not necessary, bro. Fine. Chalo, let's move on to the next question. Drying agent which can react with CO2 and it removes water as well. Quicklime, yes. CaO plus CO2 gives you carbonate. CaO plus H2O gives you hydroxide. Simple question. Basic 9th class stuff. Hold on. Okay. I was scared they've taken out a wire, but no, that wire was already out. Chalo, let's go to the next question. In which of the following compounds the nitrogen atom exhibits negative oxidation state? Just write the compounds and you'll have the answer. Sodium nitrate, NaNO2. Sorry, nitrate to hoga NO3. Yeah. NO. Sodium azide, NaN3. It's very hard to form this compound. Sodium nitrite, NaNO2. है ना? These are the structures. My dear friends, let's calculate the oxidation states. Sodium is +1, oxygen is -2. So nitrogen becomes 3 into 2, 6, 5. So this is +5. Yeah. Over here, this is plus. So oxygen will be -2. Nitrogen will be +2. Pretty obvious. NaN3. This is +1. So overall oxidation state of nitrogen, I am not saying just individual oxidation states. Overall average oxidation state of nitrogen will be 1/3 -1/3. तो आंसर तो आ गया सोडियम अजाइड. इसमें भी कैलकुलेट कर लो. दिस इज +1, दिस इज -2. So 4, 3. Nitrogen over here is in its +3 oxidation state. So the only structure over here which has nitrogen in its negative oxidation state is sodium azide, NaN3. So this is something that you needed to remember. याद रहता तो हो जाता है. If you know the structure of sodium azide, great. If you don't know the formula, you won't be able to do the question. Anyway, let's move on. In which reaction the product is not correctly given? Okay, in which reaction the product is not correctly given? It asks incorrect. ठीक है. First reaction is PHOCH3 reacting with Br2 in the presence of FeBr. चलो करके देखते हैं. So you have been given a methoxybenzene OCH3. ठीक है. Now my dear friends, this is activating ortho para directing. So if I do react it with bromine in electrophilic aromatic substitution, I will get a para substituted product. Yeah, ortho is not possible because of steric hindrance. Para substituted product is the major product. This one is a meta product. Do you see? OCH3 is meta to the bromine. This is not correct. Option number A is not correct. But again, as I told you, in NEET you have to read all the options. So let's look at the second option. Second option says PHCOOH plus CH3CH2Cl in AlCl3. Let me write the reaction for you. You have C double bond O single bond OH reacting with ethyl chloride under AlCl3. You want to do a Friedel-Crafts alkylation. My dear friends, Friedel-Crafts alkylation over here, I'll tell you, is not possible. This is a statement that you should remember. It is given in books. I'll tell you the reason as well. Benzoic acid is very useless for Friedel-Crafts reaction. FC bolo to Friedel-Crafts. Okay. Remember this. Why? First of all, benzoic acid is an electron withdrawing group. This is deactivating. So first of all, it deactivates the ring. Second, my dear friends, you have these lone pairs on oxygen. These lone pairs can combine with the AlCl3. AlCl3 kya hai? AlCl3 is a Lewis acid. So you can give one of the lone pairs over here directly. You can give one of the lone pairs over here directly. So AlCl3 is not free for catalyzing the reaction only. Phenols, anilines, benzoic acids, they don't give you Friedel-Crafts reaction because the substituent over there, benzoic acid or your OH or NH2, will directly react with AlCl3, stopping its catalytic behavior, stopping its Lewis acid behavior. Okay? So the thing is that benzoic acid is very useless for Friedel-Crafts. Phenol also doesn't give Friedel-Crafts, even though it is activating. It starts reacting with AlCl3 directly. Aniline, same thing. It is activating, but starts reacting with AlCl3 directly. Phenol and aniline are very bad for Friedel-Crafts. Benzoic acid it is still possible. Okay, if in the laboratory you can force it to happen, it will happen. But in your books, in theoretical knowledge, we say that it is not possible. So this particular product is actually not possible. So both A and B are wrong. This reaction is very simple. You have benzene with some alkyl chain, KMNO4H positive, it will oxidize it to the carboxylic acid. Last one of the simples are, this is a basic reaction from hydrocarbons chapter. Do you remember? To create acids, carboxylic acids, maybe you have read this chapter. Whenever you have benzene and some alkyl chain, if this alkyl chain has an alpha hydrogen, this is the alpha carbon. If it has an alpha hydrogen, no matter what the alkyl chain is, if you have like this big an alkyl chain, farak nahi padta, that alkyl chain will get oxidized to benzoic acid. Simple reaction. That is something that's possible. The rest of them, not much. Cool. So yeah, it was a tricky question. A lot of you would have just taken A as the answer. Tricky question. Good question. Let's move on to the next one. Which one of these is not a resonating form of phenolate ion? Basically, this is some ion that is given. You have to tell me which one of these is the incorrect resonating structure. You have to tell me which one of these is the incorrect resonating structure. Just look at it carefully, you will give me the answer. Look at this carbon. क्या बेवकूफ सोच रखा हमको. These people think that we are dumb. Pentavalent carbon. Have you ever seen pentavalent carbon? If you've seen pentavalent carbon, then you are not living on this planet Earth. You are living in some other parallel universe apparently. Carbon cannot have 5 valency. This is an incorrect structure. Option D is the correct answer. Yeah, just have to look for hints and ghatiya question hai bhai. Let's move on. Hybridization of central atom changes for which of the following molecules when it undergoes dimerization? This is a little weird. Okay, this question, it is a little weird. ओके, थोड़ा सा घटिया क्वेश्चन है ये. कैन यू सी व्हाई एंड हाउ इट इज अ घटिया क्वेश्चन? कैन यू सी हाउ एंड व्हाई इट इज अ घटिया क्वेश्चन? सोच के बताओ थोड़ा. So दोस्तों, the first structure that has been given to us, CF3, okay, this actually should be a carbon free radical. They should give you this dot over here. It is a carbon free radical. Yeah. So when a carbon free radical dimerizes, it will give you C2F6. So these are fluorines. So my dear friends, over here the carbon is sp3 in nature. You should remember that the unpaired electron always lies in an unhybrid orbital. Okay, it has been found in chemistry that carbon free radicals are planar in nature. Attack on them can happen from both sides. So this guy is an sp2 carbon. So the answer over here is A. ठीक है. The second structure is ClO3. यहाँ Ci लग रहा है ये. Okay, ClO3 also you dimerize, you will have the same sp2 chlorine. NO2 you dimerize, you will have the sp2 nitrogen. So in all the cases it is fine. Sorry, in ClO3 you will have sp3 chlorine. Yeah, but anyway, whatever the case may be, घटिया सा है थोड़ा ये. ठीक है. It's not a very good question. They should have mentioned that it's a free radical. They wanted you to figure it out on your own. Okay. New arrival asking why you not done thermodynamics. Bro, we are doing thermodynamics. 2 lectures are over. Tomorrow is the 3rd lecture. Don't worry. Okay. ठीक है. बिल्लियाँ सो गई भैया. The cats are now sleeping. So what my kittens do is they wake up, they play for 2 hours, then they sleep for 4 hours. Then again they wake up for 2 hours, then they sleep for 4 hours. So in the 7 p.m. class they were sleeping, then they woke up, then they were playing over here, and now they've again gone back to sleep. That's what kittens do. That's what they're doing. Anyway, थोड़ा सा take this question with a pinch of salt. Anyway, थोड़ा घटिया question है. Okay. Which of the following can reduce Tollens reagent? My dear friends, this is a very good question. Tollens reagent is what? Ammoniacal AgNO3. Yeah, ammoniacal AgNO3 is your Tollens reagent. Yeah, ammoniacal silver nitrate is your Tollens reagent. So when that silver reacts with ammonia, it becomes Ag positive, NH4 negative, something like that. Yeah. So Tollens reagent is essentially an oxidizing agent. And we know Tollens reagent can show tests with a bunch of things. Tollens test is used for aldehydes. Okay, great. Apart from aldehydes, Tollens test can also be used for alpha hydroxyketones. Okay, alpha hydroxyketones. It can also be used for formic acid. Okay, formic acid, and it can also be used for oxides. These are not usually discussed. Aldehydes, everyone knows. Aldehydes are converted to acids. Alpha hydroxyketones, what do they look like? I'll show you. This is your alpha hydroxyketone. If you put this in your Tollens reagent, it will give you a structure like this. So alpha hydroxyketones are oxidized by Tollens reagent. Formic acid, your HCOOH, is essentially converted to CO2 plus H2O using Tollens reagent. Then you have oximes. Oximes, my dear friends, are NHOH, something like this. Yeah. So these guys are also converted to R N double bond O. ठीक है. Oximes can also be converted to this structure via Tollens reagent. So formic acid, oxime, aldehyde, all of these will give you Tollens reagent test. So this is very interesting. All of these can reduce the Tollens reagent. A lot of you will choose the aldehyde as the answer. Formic acid and the oxime can also give you this test. Very nice question. Okay, चलो आगे चलते हैं. If the distance between Na positive and Cl negative ions in NaCl crystal is A, the edge length of the unit cell is? People, very simple question. I'll show you the NaCl structure. Okay, just a second. Yeah. Let me show you the structure of NaCl unit cell. Can you see the structure? Yeah, can you see the structure on the top over here? यहाँ दिख रहा होगा structure. So my dear friends, this NaCl structure that we have, okay, चलो यहाँ पे दिख रहा है आपको, it's visible, that's good enough. So this NaCl structure that we have, let me maximize the Google Chrome. क्या हो रहा है, रुको, कहाँ चला गया ये? Hold on people, this is acting a little weird, my laptop. Just a second. तब तक के लिए structure देखो, you will get the answer. हाँ, now it should be visible. हाँ, ठीक है. So in the NaCl structure, can you see chlorine is right next to sodium, is right next to chlorine? Yeah, chlorine right next to sodium, right next to chlorine. So if I look at one of the edges of NaCl structure, okay, अब मैं यहाँ पे सीधा एक edge बनाऊंगा. Fine. If you look at one of the edges of the NaCl structure, this is the chlorine, and right in the middle is your sodium. This is the edge. So radius of chlorine plus radius of sodium is equal to h by 2. है ना? यहाँ पे चलो लिखते हैं इसको e by 2 because a is already given to us. Yeah, this is h by 2. तो क्या दे रखा है यहाँ पे? If the distance between Na positive and Cl negative ions is a, this is given to us as a. So h is equal to 2 times a. ठीक है? This is a simple question. This is something that has to do simply with the structure of NaCl. So if you remember the structure of NaCl, Na6Cl6 Na4Cl4 structure, ठीक है? तो it's a very simple question. Nothing complicated about it anymore. चलो next question करते हैं अब. The incorrect statement regarding cellulose is, cellulose is what? Cellulose is what? Again मैं cellulose का structure भी दिखाता हूँ आप लोगों को. If you look at the structure, you will realize what cellulose is. कुछ अच्छा सा structure दिखे तो मैं दिखाता है. Just 1 minute. I'm not getting a good structure. चलो ये देख लो. This. Can you see the structure? Cellulose. So cellulose is basically just a polymer of glucose. Okay. Cellulose is something that is found in trees, etc. Yeah. So cellulose is just a very long branched polymer of glucose. So yes, it is a polymer of D-glucose. Okay. It is a polymer of D-glucose. That is absolutely correct. It has beta-1,4 glycosidic linkages. It is used for making rayon fibers. These are just factual informations about cellulose. Rayon is, a fiber that we use in some clothes, etc. And beta-1,4 glycosidic linkage, the linkages that are there are beta-1,4 glycosidic linkages, factual parts. And then finally, it can be obtained by polymerization of D-glucose in the lab. No. The thing is that cellulose is found naturally. Cellulose is found in nature, but in the laboratory, scientists have not made it yet. They have not tried because it is very easily available in the nature. So in the laboratory, no one synthesizes cellulose. It's very hard to do so as well. Okay? So ये नहीं मिलता. This is the incorrect statement. Since you are NEET students, I am pretty sure you know this better than I do. Yeah, you are much more expert at biomolecules than I ever will be. Chalo, for adsorption of gas on solid surface, the plot of x by m versus log p is linear with a slope of. यार ये कर दी ना इन्होंने वही घटिया बात. Yeah, again they've done that very bad pointless thing of asking a straightforward question. यार Freundlich's isotherm की बात हो रही है यहाँ पे. Yeah, Freundlich's isotherm, people. Do you remember the logarithmic form of Freundlich's isotherm? Do you remember Freundlich's isotherms? We can simply write log of x by m is equal to log of p 1 by n plus log of k. ठीक है ना जी. x by n is equal to k times p to the power 1 by n. बेसिकली ये है ना लॉ आपका. This is your Freundlich's isotherm law. If you take the logarithmic form of that, this is what it looks like. Y equals to mx plus c. Slope is 1 by n. As simple as that. Freundlich's isotherm, basic formula from that. Okay. If you are confused about the spelling of Freundlich, this is the spelling. Freundlich. Freundlich's isotherm, basic idea from your surface chemistry. X is the amount of stuff adsorbed, m is the mass of the adsorbing substance, adsorbate upon adsorbent, okay. K is a constant, P is equal to the pressure, and N is basically an integer. That's the Freundlich's isotherm. Tells you about the amount of adsorbate on adsorbent essentially. चलो आगे बढ़ेंगे. Surface chemistry में है. If you want to revise surface chemistry, we have a one-shot class already on the channel. This question: the compressibility of a gas is less than unity at standard temperature and pressure. Therefore, my dear friends, compressibility Z can be written as, okay, Z can be written as, Z can be written as nRT by PV. Yeah, sorry, उल्टा लिख दिया मैंने. PV equal to Z nRT. So PV by nRT. Can I write this? Yeah, but my dear friends, do you realize what is this? If this is V real, this is V ideal. nRT by P is V ideal. That is how we define compressibility factor. Okay, if you've learned gaseous state properly, you know that compressibility factor is defined as V real upon V ideal. So my dear friends, if compressibility factor is less than 1, okay, if compressibility factor is less than 1, then V real is less than V ideal. Ideal volume is 22.4 liters at standard temperature and pressure. So V real for 1 mole is less than 22.4 liters. As simple as that. काफी simple question. Compressibility factor, the definition is V real upon V ideal. Real volume upon ideal volume. Chalo. What is the correct order of decreasing ionic character? My dear friends, this is a very simple question from Fayon's rules. So Fayon's rules, which a lot of people call Pajan rules. Okay, what do Fayon's rules state? Fayon's rules say that small cation, big anion, both with large charge, both with high charge, okay, high charge on both. This is the recipe for more covalent character. Small cation, big anion, more charge on both is the recipe for covalent character. So over here, cation is the same in all of the cases. Anion, iodine is the biggest anion, so that is the most covalent. So PbI2 is structure number 3, is the most covalent, so least ionic. Then you have bromine, then you have chlorine, then you have fluorine. 2, 1, 4, 3 should be the answer. Option number D. Basic application of Fayon's rules. This is the revision for Fayon's rules. Small cation, big anion, high charge on both is the recipe for more covalent character. So bigger anion is more covalent, smaller anion is less covalent over here. Fine, simple question. Let's move on to the next one. Lactose on hydrolysis with dilute HCl gives. See, lactose is something that gets hydrolyzed by lactase. Okay, lactase डालोगे तो टूट जाएगा. Lactose is basically the combination of glucose and galactose. This is again a factual question. This is a memory based question. Lactose has glucose and galactose. Okay, lactose has glucose and galactose. If you want to see the structure, this is what it is. Lactose, you put lactase, it will get hydrolyzed. You get D-galactose and D-glucose. Okay? Let me see if I can change the focus of it to make it a little better in visibility. Yellow. ठीक है. So D-galactose, D-glucose is what lactose is formed of. ठीक है. चलो जी आगे बढ़ते हैं. Table sugar is, my dear friends, table sugar is what? Normal sugar is essentially sucrose. Sucrose is a combination, like lactose is a combination of glucose and galactose. Sucrose is a combination of fructose and glucose. And most sugars in nature, I think almost all the sugars in nature are formed in their D state. Yeah, if you have a sugar, yeah, this is the first carbon that is optically active starting from the bottom. So if on the first optically active carbon, this is how you write the sugar. If this is on the right hand side, this is a D sugar. If this OH was on the left hand side, that will be an L sugar. So since you are NEET students, I am pretty sure this is an easy question for you. Sucrose is made up of disaccharide. Disaccharide bolo to two sugars are combined. So it's a disaccharide consisting of D-glucose and D-fructose. Okay, so in the straight chain structure of glucose and fructose, this OH will be on the right hand side. Okay, chalo ji, let's move on to the next question. My dear friends, thankfully we are done with today's class. So this particular question, the pair that requires calcination, this is your homework. Okay, this is your homework. This is something that you have to do as your homework. Answer in the comment section down below, please. This is a simple question from metallurgy, factual question. You can read metallurgy, you can see the metallurgy marathon class that we've done on this channel earlier to remember more about such cases. Fine. So this is your homework question. Give me the answer in the comments. Tomorrow again, starting at 8:30 p.m, we will solve another NEET mock test, which will be test number 104. Okay. So people, today's class is thankfully done. What I will do is I will share the PDF of today's class with you guys because it has the solutions. Just sharing it with you for reference. Then I will chat with you for a little while. चलो जी, तो इसको करते हैं share. Let's share it with all of you. Just give me a moment. All right. A lot of people are worried about PUBG being banned. PUBG ban हो गया तो कोई और first person shooter खेल लो यार. Okay, so I've put the slides in the comment section down below as well, and I've pinned the comment. Done. Fine. So people, now we can chat for a little while and then I will end this class. Meme नहीं आया क्या आज? Let me see. आना तो चाहिए. Shahsod, you just think that you forgot the physics formulae. Practically speaking, that is not possible. Your subconscious memory always retains a lot of things. Just do some questions on physics and you will be able to retain those formulae once again. Just do basic questions. Just solve an NT mock test. Yeah. आज मीम नहीं डाला क्या? हाँ, आज मीम नहीं डाला. I don't know why. मैं डलवाता हूँ, ठीक है? My team generally deals with it. I'll get that done. Don't worry. मैं डलवा देगा मीम. Okay. अभी ये free होके मैं खुद ही डाल दूँगा. Alright. Yeah, there are so many other first-person shooter games, man. We used to play Counter-Strike when I was in school and college. I used to play Counter-Strike on the laptop. Okay, and Counter-Strike is much more involving than PUBG. But I am pretty sure now in the days of mobile phone, there are other games which you can play on the mobile phone. Just play some other first person shooter game, man. Prabish is asking, is NEET completely NCERT based? 99%, man. Arijit is saying, sir, inorganic metallurgy broth problem. See, you can try improving it. We just watch the marathon of metallurgy that I've taken. More than that, if you don't see the benefit, if you think lots of time is being spent just for 1-2 questions, leave it. Okay. Sri Charan is saying, can we expect NEET exam to be tough? It won't be tougher than this. Okay, this was a good NEET paper actually. All right. Satyapriya is asking XCF8 exists. Nah. Kyaru, I'm glad you're enjoying. Anirudh, lactose का structure Google मार ले मेरे दोस्त. Anirudh, there's nothing to draw in that structure. It's a standard structure you can see from Google if you want. Acha, Srivatsan gave exam today and he's saying your session helped me in today's exams. I am so glad to see that. Dhiren, just chill bro. ज़्यादा tension लेने की ज़रूरत नहीं है. Mock test is a mock test. Main test is a main test. Your mindset will be different. Mock test में जितना number आया, okay, fine, doesn't matter. Main test में फोड़ देना, ठीक है? Just feel good about yourself. As I said, go to the mirror and tell yourself you're awesome. Pretty sure you'll do well. Okay. Nishant, hard questions we will do eventually, bro. Right now, since people are busy giving JEE mains, so for this week and next week, we will be solving the NEET mock tests. Once NEET is done, then we will start the Take 5 series once again. And for all of you who have joined me with the Take 5 series, you know that we solve really good advanced problems in the Take 5 series. Yeah, the questions are so good that sometimes it takes like half an hour to solve just one question. So yeah, we will start that once again eventually. Gautam is asking, why don't you take Menti? Because it is just a time waste for me and you. क्या हम नाचने थोड़ी आए अब? Menti. I don't like to do that personally. Other people do. Good for them. Okay, for me, I think that NT is for 6th, 7th class students. For Menti, I have to put all of these questions into options. Too much work for everyone. Pointless stuff. Anyway, so chalo doston, that's it from my side for today's class. Thank you so much for joining in. In case you want any strategy, in case you want to know important topics, just check out the strategy sessions. They are in the playlist of our channel. You'll see a playlist called strategy. Yeah, and you can check that out. If you want to revise any chapter, there's a series called Let's Revit on our channel. You can check that out. So that's it for today's class. If you enjoyed it, please hit that like button, stay subscribed, because I will see you very soon tomorrow at 8:30 with test number 104. Bye bye.